we have 3-3 and 3-4. It asks us for number 7. There's 3 things that we have to do. We have to write an equation for a line that passes through those 2 given points. Then we have to write another line that is parallel to that given point. Then we have to write a line that is perpendicular to those 2 points. All right. So give me a second. I'm going to set this up to be neater so we can work with the problem. All right. Let's look at A. The first one asks us to write an equation that passes through these points. So we want to grab some information from here. So we want to first get the slope, okay? So M is considered to be the slope here. So the slope goes from what to what? So I'm just going to draw this line right here, which is, that represents the line here, okay? So that looks like it is going, the slope has no rise, so that is 0. And the x is changing how much? 1, 2, 3, 4. Okay, so that is just 0 slope. Okay, so the slope here is 0. Okay. Now we just need the y-intercept. The y-intercept is the point in which it crosses the y-axis. That value, this is 2. This 2, 4, 6. Okay. So this is b value is going to be equal to 6. So if we write the equation is y equals the m, which is the slope, the x is the variable. We're going to add, then we're going to add the b, which is the y-intercept. Okay, so y is equal to, the slope is 0. Then we plug the x plus the y-intercept here, it is 6. No one writes the 0x, so it would just be y is equal to 6. We would like now a equation of a line that is parallel to that, okay? So the slope is m is equal to 0. The slope that is parallel to it, m parallel, is going to be its same thing, so that's going to be equal to 0. So we can just write the same equation from before. Y is equal to 0 for the slope, x plus the y-intercept, which is just b. We can pick any value here besides 6. So let me just pick the value of 8, okay, or 10. How about 10? Okay, so if we want to graph this, okay, this is going to be the red line. That would be this line right here, okay? So that is the same slope, which is its flat line, with the y-intercept of 10, okay? Then we want to find its perpendicular slope for that, okay? So we have m, the original m is equal to 0. We want to find its perpendicular slope. So this is weird, okay? The perpendicular slope, so that's a perpendicular symbol, of 0 is actually undefined, okay? Because the reciprocal, the opposite reciprocal of 0 is undefined. You can't really divide by 0, all right? So you can't really write the equation. You can't really write y undefined. So the only way you can actually write it is using your x. So it is x equal to some value. You could pick any value that you want. So I'm going to pick x is equal to 2, okay? And I'm going to show you the line here. Do you see here? It is just a, it's just a vertical line. So I want you to notice that your original equation was a horizontal line. It was flat, left to right. The parallel line was also horizontal, left to right. So this is y equals to 10. The perpendicular from horizontal is vertical, okay? So that is why it is x is equal to 2. Let's look at B here, okay? We now want to do the same process from before. We want to write an equation of a line that passes through these points. We should find the slope first, okay? Let's find the slope. So what is the slope? Let's zoom in closer and see how it changes. So this is 2, so this is how much is it in the y direction. So it's 1, this is 2, so 1, 2, and this is another 1, 2. So it went up, so it went down 1, 2, 3, 4, 5. Okay, so did it go from, yeah. So delta y is equal to -5. It went from 7 to 2, so that's -5. How much did it go delta x in the x direction? So let's do 1, 2, because you see how each unit here is 2, 3, 4, 5. Okay, is delta x also equal to 5? Let's see, 1, 2, 3, 4, 5. Oh wow, so it is -5 over 5, which is just equal, so the slope's just equal to -1. That's amazing. Okay, so all we have to do now here is get the y-intercept. Okay, the intercept will look something like that. It's actually very difficult to get the y-intercept here. Okay, so I will write that the y-intercept is very difficult to get here. Y-intercept is difficult to obtain. Because it is difficult to obtain, we can probably use another equation. The other equation that you can use is this. Okay, you can use y minus y1 is equal to your slope, which is m, parentheses x minus x1. Let me make that in blue and close the parentheses. All right, so please understand that x1 comma y1, it's just any point. So the point that I'm going to be using is this one. Okay, no, actually I'm going to use 3 over 2 because the numbers are prettier. Okay, so I'm going to use this, right? So we know that x1 is equal to 3. Then we know that y1 is equal to 2. So just plug it in. Nothing happens to the y. The y1 becomes the number 2. That equals to your slope of -1. Parentheses x minus what is your x1, which is 3. Close the parentheses. There you go. But we want like this in a neater way. So y minus 2. Let's distribute. -1 times x is -x. -1 times -3 is +3. Add 2 to both sides. You get y is equal to -x plus 5. So that y-intercept is 2, 4, 5. Looks like it's somewhere here. And it looks like that was close. So yeah, so that equation makes perfect sense. So that is the equation that passes through those 2 points. Now we would like to obtain its parallel line. Okay, so for it to be parallel to this line, the slopes have to be the same. So m is equal to the m parallel. So m parallel is equal to -1. They have to have the same value. Okay, so the equation is y is equal to what? Mx plus b. It could be any point, any y-intercept. Okay, so just erase the m. We can now plug in the value of the -1. Then we can erase the y-intercept. It could be any y-intercept here. I'm just going to make that, let's see. Make that, let's see. Ooh, 0. Why don't I just make it 0? Okay. So I can make that 0. So there you go. That equation would work. So let me graph this. So the original one is going to be the black line. Okay, so I try to make this a little bit good. right? So the original one is the black line, right? The parallel to that would be the same line, right, of the negative slope, but it starts from the y-intercept of y, okay? Now, let's see if we can find the perpendicular slope of that. So, if m is equal to -1, the perpendicular slope, look, it's the upside down t, is equal to opposite, so the negative becomes a positive, and you flip the 1. 1 over 1 is just 1. So the perpendicular slope is just a positive 1. Okay, so let's write the equation. The equation is y is equal to mx, so m, and then you have the x plus the b. And we know that the slope here is going to be a positive 1. And the y-intercept can be anything that you want. So you know what? I'm going to make my life easy. I'm also going to make the y-intercept here also equal to 0. Okay? And let's see if that makes sense. Right? Okay? So this is going to be the parallel line, I forgot to label, was in red. And I'm going to make this the, how about the blue line? Okay, the blue line is going to be the perpendicular line. So we start from 0, 0, and the slope is up 1 across 1. So there you go. Okay, and you should see that blue line is perpendicular to those parallel lines. Okay. Let's now take a look at C. Okay, same thing here. We have to find the slope first, but this time, okay, we also have the image. So let's just count, and it looks like it's positive, okay, because we're going we're looking at it right to left. So let's find the slope. What is the slope here? All right, so let's count. So you're going from -8 all the way to 8, okay? So it looks like you go up -8, so you went up 8, then you also went up another 8. So delta y is equal to 16, okay? Then we're going to go to the left. We are starting from -8, so hold on. So delta y was equal to 16, okay? Then we want to look at the x direction. So you're starting from -8 and you're going to this value of 1. So from -8 to 1, how much are you traveling? Okay, so it's 8 here plus another 1, so that is 9. So your delta x is 9. All right. Okay. Now let's just plug it in. The slope is 16 over 9, which can be simplified. Looks like, I think 16 over 9 can be simplified. Actually, it can't. Okay, so let me just double check the slope to make sure it's right. Okay, by just using another equation. Let me see. Yeah, so I just plugged it into the slope formula and it did work. It is still 16 over 9 and it's positive. Okay, all right. So we need to find the y-intercept though. So that's going to be the difficult part. All right, so it looks like we're going to be using the same equation from before. We're going to be noticing that the y is very difficult to obtain, right? So we will have to use the point slope form, okay? So let's just grab this point here of 1, 8, right? And use that as our point. All right. So your x1 is going to be the x value of 1, and then your y1 is going to be your 8. All right, so let's just plug it in here. Okay, I'm going to grab this equation. I'm going to erase the y1, and then I'm going to plug that in as 8. Now I'm going to erase the m, which is the slope, and that looks like that is 16 over m. No, 16 over 9, right? Good. And then the y is, and the x1 is blue, and that is 1. Okay. All right. So we don't like this format. We want to make sure it's y intercept form. So we have to distribute. 16 over 9 times x is 16 over 9x. 16 over 9 minus negative 1, it is negative 16 over 9. Okay? You want to add 8 to both sides. So it is y is equal to 16 over 9x. Then you want to do this in your calculator. Okay? You want to do negative 16 over 9. You're going to add that to 8. And the fraction of that is plus 56 over 9. Okay, that's why it's very difficult to actually get the y-intercept here, because it's a weird fraction. Okay, the decimal version of this is like 6.22. Okay, and yeah, it should, wait, hold on, does that make sense? Hold on, let me draw this to see if the y-intercept makes sense. Does it work? Yeah, so 3, 6, yeah, it looks right. It looks, yeah, it looks, yeah, it does look like it's in the 6th spot. Yeah, good. Okay, now we want to find a line that is parallel to that. Okay, so parallel means it has to have the same slope. So the m has to be equal to the m parallel slope. The slope of the regular line is parallel to the slope of the next line. So the m parallel slope is going to be also 16 over 9x. Okay, you can pick any value that you want. So it's y equals to the slope, which is 16 over 9x. Now you want to add a y-intercept. We can use any value that we want. I'm just going to pick the value of, let's see, negative 6. Okay, so the equation would be y is equal to 16 over 9x minus 6. That would be that equation. Okay, so if the first one looks like this line, let me have that here. Okay, that is the black line from part 1. Then this is going to be the blue line. Okay, I'm going to make this the blue line, which is parallel. We know that it is the same slope. We just have to move it to, this is negative 3, this is negative 6. There you go. Okay, now we want perpendicular. Okay, the m perpendicular. The slope needs to be perpendicular. So we want to see what is the opposite of 16 over 9. Positive. So what's the opposite of positive? Negative. Reciprocal. The 16 over 9 becomes 9 over 16. So that's your new slope. So the equation can be y is equal to, that slope is very important, negative 9 over 16 x. And we can make the y-intercept anything we want. I think I'm going to make it, I'm going to make it 0 plus 0. Okay. All right, plus 0. Okay, and I'm going to grab that. It looks like this. Oh, sorry, the slope is off. Okay, so it's just something like that. Okay. All right, there you go. You don't need to really graph it, but I wanted to show you the visual of how it looks like. Okay, so there you go. That is how you find the equations. One parallel, one perpendicular, and how to write the general equation. Okay, A was easy because you can just find using y equals mx plus b. But please understand, B and C required you to use the point slope because you couldn't get the y-intercept very easily.